for this polynomial summative review, problems 10 through 13. 10 through 13. Let's start off here with number 10. Now, and understand that when we first introduced factoring to you guys, we started out with greatest common factor, all right? GCF. And I'm going to tell you right now, problem 10 and problem 11 are just GCF problems, meaning you find out what they have in common, you factor that out, and you can pretty much wring your hands of being done with these problems. If you look at this first problem, you have a 7 and a -9, and they have no common factors other than 1. But if you look at the m and the m squared, they both do share at least one m. So we take that m and we're going to factor it out. And we're going to divide a single m out of each one of these. And if I divide that m out of there, the first term leaves me with nothing but a 7. And the second term, I'm still going to have an m left, right? Because in the first term, those m's cancel all together. Here, I still have 1 left, so I end up with 9m. And I'm going to be honest with you folks, that's all you can do. These first couple problems of factoring are simply going to be greatest common factor. Number 11, same exact situation. Excuse me. You look here and you say, does the 6, the 24, and the -12 have a common factor? Most of you would know that, hey, they're all divisible by 6. So I'm going to take a 6 out of there. Then you come back and you look at, don't forget to look at variables. That first term has an x cubed, the second term has an x squared, and the last term has an x. That means that they all have an x in common. Now, what do you have left after you divide that 6x out of each term? So if we divide each of these terms by that 6x, what would be remaining? Well, in that first term, the 6's would cancel, one of the x's would cancel, and I'd be left with 2. So I end up with x squared is all I'm going to have that remains from that first term. In the second term, 24 divided by 6, I'm going to get a +4. And if one of those x's cancel, I'll still have 1 remaining. And in the last term, -12 divided by 6 is -2, and the x's will cancel all together. So this would be all I'd have. I'm going to move it down just a smidge right here. Whoop, didn't mean to move that. I apologize. Right there. Sorry about that. Move this solution down a little bit. Obviously one piece at a time. Oh, give me that parentheses. There we go. All right, and that's going to be our solution to number 11. Excuse me. Number 12 is a different ball game. Number 12, there is no greatest common factor. There isn't one thing that all these three terms have in common. They don't all have an x, and they're not all divisible by a specific number. So this is an entirely different problem in the fact that we have ourselves a quadratic, that means it has that power of 2, trinomial. So we use our box method on this particular problem. And you take the two terms that fill in the box are the x squared and the 35. All right, so you put the x squared in that upper box, that's 1x squared, and +35 right there. Now we multiply that diagonally and we get 35x squared. Well, we're just going to take the 35. We know it's going to be an x squared. And we multiplied 1 times 35 to get that 35. Now I'll be honest, we are looking for two numbers that multiply or have a product of 35, but also a sum of +12. We're looking for them to multiply to give me 35, but add up to 12. And I'm going to tell you right now, 1 and 35 aren't going to cut it. You start thinking of other number pairs that multiply to give me 35, and 5 and 7 come to mind. And the cool thing about 5 and 7 is they multiply to give me 35, bonus, and they add up to 12. So that 5x and that 7x will go in our box. Now we pull out common factors vertically here. 7x and 35 have in common a 7. X squared and 5x have an x in common. So that's going to be our first factor, x plus 7. Now horizontally, x squared and 7x, what do they have in common? An x. What do 5x and 35 have in common? They're both have a factor of 5. So there's my second factor, and that is the answer to number 12, factored form, x plus 7 times x plus 5. Now we move over and we repeat that exact same process for number 13. draw our box. We take our x squared, and we take our negative 42, and we put them in the box. All right, we multiply those two together diagonally. We get negative 42 x squared. Now, we already know it's going to be x squared, so I'm just going to write the negative 42. Now, what did we just multiply? We multiplied a 1 and a negative 42 together to get that negative 42. But we need these factors, 1 and negative 42. Ideally, they're going to add up to positive 1. That's what we need them to add up to. They're going to multiply to give me negative 42, but have a sum or add up to positive 1, and that's not going to cut it. Another combination of numbers that would multiply to give me 32 would be like 3 and negative 14. But if we add 3 and negative 14, we get negative 11. That's still not the positive 1 we wanted so badly. All right? How about 6 and negative 7 would give me negative 42. But if I add those together, I get negative 1, not positive 1. But now we're on to something, because what if we multiplied negative 6 and a positive 7? Would those add up to the positive 1 that we want? Yep, this would be our winning ticket. So we put the negative 6, let's pick an x, and a positive 7, and we ask ourselves, what do 7x and negative 42 have in common? They both are factorable by 7. What do x squared and negative 6x have in common? They're both divisible by x. So we have one of our factors is going to be x plus 7. Now we go horizontally. X squared and 7x. What do they have in common? They're both divisible by x, so we factor out an x. And now negative 6x and negative 42. Do you see how they're both negative? So we want to take out a negative, and they're both divisible by 6. And now we have our factors, x plus 7 times x plus 6. And those will be your solutions for 10, 11, 12, and 13.